right, class, the last section of chapter 3 is section 3.3, which is applications of systems of linear equations. So that means word problems. We've seen problems like this before. So here I have a rectangular soccer field, may have a width between 50 and 100 yards and a length between 100 and 130 yards. One particular soccer field has a perimeter of 320 yards. Its length measures 40 yards more than its width. What are the dimensions of this field? So I've already been given quite a few pieces of information. I've been told that my perimeter, friendly reminder, the equation for perimeter is 2w plus 2 times the width plus 2 times the length equals the perimeter. So I have my perimeter is 320 yards. So I know I have the equation 2w plus 2l equals 320. I also know that the length of my field measures 40 yards more than the width. So if I wanted to make these two equal, I would take my length, set it equal to my width, and add 40 to my width. That would help us keep this balanced. Now, this is a system of linear equations. We've already solved a problem like this, so you have already technically solved word problems using systems of linear equations, but you didn't know it. I'm so sneaky, right? So what we can do is we can solve this via substitution. So I'm going to substitute w plus 40 for l. So I have 2w plus 2 times w plus 40 equals 320. That means 2w plus 80 is 320. I combine like terms and subtract 80 from both sides. I get 4w is 240. So w equals 60. Now that I found my width, I can go ahead and find my length by plugging it back into either of our original equations. So if I have L equals W plus 40, and I found that W is 60, L equals 60 plus 40, so L equals 100. And remember, if we want to check our answer, we can substitute both of these back in to our original equation, and we would find that we have a perimeter of 320. In this second problem, we're going to solve this system of equations using elimination. So, the National Football League and National Basketball Association seasons from 2015 to 2018, it would cost you $241.84 to get 2 football tickets and 1 basketball ticket. It would also cost you 1 football ticket and 2 basketball tickets would have cost $204.74. I like this word problem because it basically just gives you your system of equations. I have that 2 football tickets and 1 basketball ticket is $241.84. And I have that 1 football ticket and 2 basketball tickets is $204.74. I want to go ahead and solve this by elimination. Let's pick f to be our focus variable. So I can multiply this equation right here by -2, and I would get -2f minus 4b equals -409.48. I want to add that to my original equation. These cancels out, and I get that -3b equals -167.64. I divide both sides by -3. I get that b equals 55.88. So $55.88 was the average price of a basketball ticket. I can solve this. I can now solve for the price of a football ticket by substituting 55.88 back into my original equation. And I just picked the first one, but you could have picked the second one. Either way, it would give you the same answer. So I have 2f plus 55.88 is 241.84. I subtract 55.88 from both sides. I get that 2f equals 185.96. I divide both sides by 2. I get that the average football ticket cost $92.98. So now I know the average ticket prices for 2 sports. Our third example is one of the most beloved chemistry examples, right? So how many ounces of each 5% hydrochloric acid and 20% hydrochloric acid must be combined to get 10 ounces of solution that is 12.5% hydrochloric acid? So let's let X be the amount in ounces of the 5% solution, and we'll let Y be the amount in ounces of the 20% solution. I know that if I mix X and Y, I have 10 ounces. I also know that at the end, I want 12.5% hydrochloric acid. So the amount of acid in X, which would be 0.05 times X, plus the amount of acid in Y, is 10 times its concentration, which we're going to write as 1.25. So this gives me, let's make it a brighter color, 0.05x plus 0.2y equals 1.25. Now, in order to not have to work with decimals, I'm going to go ahead and multiply both sides of this equation by 100. Remember, what I do to one side, I can do to the other, and the equation will remain the same. So that gives me 5x plus 20y equals 125, and that's going to be a little bit easier to work with. So what would I multiply our first equation by in order to get our x's to cancel out? Well, that's going to be negative 5. So I have negative 5x minus 5y equals negative 50. I'm going to add these together. I get that 15y equals 75. Divide by 15. I get that y equals 5. I know that x plus y equals 10. Since y is 5, x is 5 as well. So I would need 5 ounces of each concentration in order to make a 12.5% solution. All right, class, the last problem in this chapter is going to be a word problem involving a system of 3 equations. So let's say a company produces 3 flat screen television sets, models X, Y, and Z. Each model, X, requires 2 hours of electronics work, 2 hours of assembly, and 1 hour of finishing. Each model Y requires 1 hour of electronics work, 3 hours of assembly, and 1 hour of finishing time. Model Z requires 3 hours of electronics work, 2 hours of assembly, and 2 hours of finishing time. There are 100 hours available for electronics, 100 hours available for assembly, and 65 hours available for finishing per week. How many of each model should be produced each week if all available time must be used? So we're going to have to set up 3 equations. We're going to have an equation for electronics work, assembly, and finishing time. And where these 3 equations intersect will tell us the exact amount of models X, Y, and Z that we can produce. So I have 2 hours of electronics work for model X, 1 hour of electronics work for model Y, and 3 hours of electronics work for model Z. I have 100 hours available for electronics. I then have 2 hours of assembly for model X, 3 hours of assembly for model Y, and 2 hours of assembly for model Z. I'm given 100 hours for assembly. Last but not least, finishing. So I have 1 hour of finishing time for X, 1 hour of finishing time for Y, and 2 hours of finishing time for Z. And I only have 65 hours a week for finishing. Here is my system of 3 equations. So what I need to do is I need to pick my working equation. Let's go ahead and let this be our working equation. And we're going to start out with our focus variable being X. So if I take my first equation, which is 2x plus y plus 3z equals 100, what would I need to multiply my working equation by in order to cancel out our x's? Well, that's going to be a negative 2. So this gives me 2x plus y plus 3z equals 100, and negative 2x minus 2y minus 4z equals negative 130. My x's cancel out. I have negative y minus 3z equals negative 30. Next, I have 2x plus 3y plus 2z equals 100. This is my equation for assembly time. And I am again going to take xy plus 2z equals 65 and multiply it by negative 2. So my x's will cancel out. That gives me 2x plus 3y plus 2z is 100. And negative 2x minus 2y minus 4z equals negative 130. My x's cancel out. I have a positive y minus 2z equals negative 30. Now I have a system of two equations in y and z. I can go ahead and add these together in order to cancel out my y. If I add them together, my y's cancel out. I have negative 5z equals negative 60. So I then have that z equals this is a 1z. So I have negative 1z. So now if I have negative 1z and 2z, I have negative 3z. I divide both sides by negative 3. Z equals positive 20. Now that I know z, I can solve for y. So if I take y minus 2z equals negative 30, that was my equation right here. That gives me y minus 2 times 20 equals negative 30. So y minus 40 equals negative 30. I find that y equals 10. So I'm getting my ordered triple together here. I've got x still left to solve, but I know y is 10 and z is 20. So I can make 20 of model z and 10 of model y, and now I just have to figure out model x. So let's take x plus y plus 2z equals 65. I have x plus 10 plus 2 times 20 is 65. So I have x plus 50 equals 65. I find that x equals 15. So I can make 15 of the model XTV, 10 of the model YTV, and 20 of the model ZTV.